First off, I just want to say hopefully the technologies cooperate. It's really an honor to be here. It's great. We're so glad to have this opportunity to be here. As you said, to be part of an open discussion. Let's talk facts, let's talk evidence, let's talk about what needs to be done, what we need to do to get to Mars. And so I'm Andrew Owens. This is my colleague Sydney Doe. We're PhD candidates at MIT. We want to give a little background. As you mentioned, we wrote a study last year. We wanted to acknowledge our co-authors on that study. There's Sam Schreiner and Koki Ho, who both graduated. Sam's now at JPL. Koki is an assistant professor at UIUC. And also our lighting system fades in and out, but Professor Olivier Deweck, who's our thesis advisor out there. So we are really excited about spaceflight in our lab. We look at mission studies, we look at strategic engineering, technology development, looking at what does it take to get us from here to Mars, wherever we're going next, what does it take? So one key point that we wanted to make is this is not a debate about the feasibility of exploring Mars or colonizing Mars. I think everyone in this room can agree that humanity will settle Mars, right? Is there anyone here that doesn't think that we should go to Mars? No hands. Good, I guess based on the name of the convention. This is a debate, as you described before, about a very specific question. Is the Mars One mission plan feasible? And by examining this question, which may be yes, maybe no, then we can learn what we need to do to make Mars exploration feasible. What technologies do we need to develop? What are the major challenges that we face? So that's what we're here to discuss today. So to start off, what is the Mars One plan? I think we're all pretty familiar with it, but to cover the main points. Looking to build a colony with one-way trips, 4 crew members every 2 years, using existing, validated, and available technology, and then $6 billion for the first crew, $4 billion for the rest. First mission launches in 5 years, 2020. And the first crew landing in 2027, so that's 12 years. This is what it says on the Mars One website. And here, just laid out in a schedule, we have the first mission, in a ComSat in 2020. Then we've got a rover and a ComSat 2 years after that. The first cargo mission, 2024, 2 years after that. 2 years after that, the first crew goes. And then, from then on out, it's crew, another crew, staying on Mars for the rest of their lives because it is a one-way trip that does not have a return system. So this is the Mars One plan. This is what the Mars One website says. This is the scope. So what does this mean? It means that Mars One claims that system design, development, test, manufacture, integration, and 14 launches will be accomplished for $6 billion over the next 12 years to accomplish the first mission landing. And then every 2 years after that, Mars One will manufacture, integrate, and launch 11 systems for $4 billion continuously to sustain the crews that are on the surface. This is the Mars One plan. This is how it is described on Mars One's website. So now we're going to talk a little bit about feasibility.
So the topic of this debate is Mars One feasible? So the question is, how do you assess feasibility? So every project is constrained by 3 important factors, and these are interrelated with each other. These are cost, schedule, and scope. So this is sometimes called the triple constraint of projects, or the iron triangle. And these are interrelated, they're synergistic, and you have to look at a project holistically from these 3 factors to assess feasibility. If any of these change, then the other factors have to change accordingly. So feasibility, one way, or actually the way of assessing project feasibility is to answer the question, is the defined scope attainable within the schedule and cost constraints that have been stated? So let's apply this model to the Mars One project. As Andrew had mentioned, the scope is to permanently settle the planet Mars via a series of one-way missions with 4 crew every 2 years. They want to do the first landing on the surface of Mars by 2027, so that's 12 years from now. And the claim is that this can be done for $6 billion, then afterwards $4 billion every 2 years. So the key question that frames this entire debate tonight is, can Mars One execute the Mars One mission plan that's laid out in front of you under the cost and schedule constraints that they have specified? And so over the next 15 or so minutes, we'll be digging deeper into what it means for the cost, schedule, and scope of Mars One. How is that how are these claims made in the context of our historical knowledge, the facts that we've seen from our aerospace experience and analytical studies. And we've also color-coded some of the words in this presentation, so this green, red, blue theme will go on throughout. And so we want you to keep in mind that when you're looking at a project, you have to look at it from these three main factors: cost, schedule, scope. So Mars One has made several arguments for the feasibility of their plan. Some of them include the argument that it is feasible from a schedule perspective, and this is usually made through comparisons to Apollo. So a quote is, don't forget that when Kennedy announced the moon mission, he had less time than Mars One. Other arguments have been related to the scope of the mission. And the key argument is that because it's a one-way mission, it allows for existing technology to be employed. So it's a very long quote that Mr. Lansdorp has made. I'm not going to go through it all, but essentially the takeaway is that the technology is existing to do a one-way mission, that we have landing systems that are very comparable to that of the NASA Curiosity mission, and that life support systems are very similar to those used on the International Space Station. So let's look at each of these claims of feasibility in a little bit more detail. So let's look at the Apollo comparison argument, for example. So as we all know, Neil Armstrong stepped on the moon in July 1969, and this was 8 years after the start of the Apollo program. And to get Neil Armstrong to the moon, NASA had to develop many technologies. Here we've outlined the major technology developments, and we'll see them here. So these are the main technologies. And to land humans on the moon, in current year's dollars, this costs $102 billion. I guess we can't see the bottom of it. Now let's compare this to Mars One.
Why don't you two move over?
I'll continue on, given we're on a time crunch here. So let's look at the Mars One mission. They started in 2011, and they had 12 years left to meet their goal of landing a crew of 4 on the surface of Mars. So based on their website, this is the hardware that's required to land 4 people on Mars. So there's a lot more technologies that are required. There are a lot more instances of each technology, and each of these entails a dedicated program. And the claim is that this is $6 billion. So you're probably all thinking to yourself, this is not really a fair comparison. NASA's a government agency, Mars One is a private mission, it's a lot more efficient. So let's compare Mars One's cost, schedule, scope to a more modern day private mission. Let's compare it to Virgin Galactic. So as many of you know, Virgin Galactic is planning to develop a regular suborbital spaceflight capability. They've been at this for 10 to 11 years now, and as of November 2014, after 10 years and $600 million invested, they're still under development. If you look at the Mars One plan, they still have 12 years remaining to send humans on one-way missions to Mars, which is a lot harder than sending people 100 kilometers above us. So another argument is that technology is existing. So let's look in detail at one of the many technologies that are required. So a key cornerstone of the Mars One plan is that they'll use an intelligent robot. And essentially what this robot does is set up the habitat autonomously. And so what they're asking of this rover is for crew transport, a truck and trailer, a bulldozer, and a very autonomous, dexterous, intelligent robot. All of that in one single system, operating on the surface of Mars for at least 26 months, and without any servicing from any of the crew. Basically, no capability to repair the system. So right now we can't even do this on Earth, and this is expected to happen on Mars. So if we compare this with something that's, with another rover that's on the same schedule relatively, we can look at the Mars 2020 rover recently announced by NASA. So this is based on existing technology, it's based on the Curiosity bus, it's a scientific rover, so it doesn't have to do any teleoperating, any heavy lifting, sorry. It has core and drill, it has some technology demonstration.